Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. Yesterday we were in the process of fixing some bugs, just like bugs that we have on our bug list that I thought it would be a good time to finish sort of cleaning those up, and I would like to keep on doing that because we've got a few more issues on the issues list that I think are things that are worth cleaning up now. They're kind of small, isolated things that kind of make sense. I don't like leaving bugs in the code. In fact, on Handmade Hero, I actually am fairly usually quite a bit past my comfort level on that, because typically when I'm programming, I really don't leave bugs in code at all. But on Handmade Hero, I kind of try to bundle things up, and so I try not to jump all around more than I already have to just show reasonable game programming happen. So I'd like to kind of go through these and just get rid of some more of them that are pretty reasonable to get through. You know, we don't have a huge bug list or anything, but, there's plenty of things on here that just really, probably should be taken care of. So let's go ahead and dive in on those. Today is day 323, so if you're trying to follow along at home, you want to do day 322 source code. That's what you want to start with, because that's what I'm starting with here on day 323. So let's take a look inside the ye old project here. Get it going. Just get it on going. Ooh, hello, Visual Studio, wake up. Okay. And so my understanding was, although we did a bunch of debugging yesterday, there is one thing that I think we didn't finish. Kim, the guy who maintains, I think, the SDL port right now, was saying that we didn't handle the walking up the stairs case, he was saying, correctly, when the aspect ratio changes. So you can see there the walking up the stairs case was handled properly in this case. So now let's go ahead and change the aspect ratio and just see what happens, right? Let's go ahead here. You know what? I shouldn't be thinking in my head. This is the stream. I'll think out loud. I'll think out loud later. Anyway, point being, so in theory, if we change the aspect ratio, there's something that we're doing wrong here with respect to, and you can kind of see it doing a pretty crazy flip there, right? So we've got some work to do here. We're definitely not setting up our render targets the way that we need to set up our render targets. Let's double check to see what happens if we do that in the software render, because I don't know if we're broken in both or just one in this case. I assume that we're only broken in, so we're only broken in the hardware renderer, which is what we would expect. So let's go take a look at what's going on in the hardware renderer path for that blending and see if we can't clean that up first. I don't know if that bug is actually on here. That might not be on here. So this may just be this is just a bug that's not listed, I guess. Yeah. So this is not in there, I guess, unless I'm just looking right at it and missing it. So anyway, in here we know what case we're talking about, right? So at least there's no mystery here. We know we're talking about the render entity blend render target case, and we don't necessarily know exactly what's failing because there's a number of things that are based, like that are sort of go into making this work correctly. But one thing that I would point out kind of obviously is that the GL viewport is not working correctly, right? Like I'll just point out here, when I start going up these stairs here, well, never mind, I'm already in the software render, so that's fine. I mean the hardware render, so that's fine. When I start going up the stairs, you can see that it pops down to the bottom, right, during that transition. And so what that means is the actual base drawing is able to draw sort of outside of where the viewport regions should even be. And I don't have any idea how that's happening exactly, because in theory, that should, when we do our bind render target, right, we're doing, sorry, bind frame buffer, we're setting up the viewport and the scissor region very specifically there. Now, I guess one thing that I didn't think of is this scissor here for the clip rect. I guess maybe one thing that we're messing up there is our scissor. Is the scissor relative to the viewport, or is the scissor not relative to the viewport? Because the scissor isn't relative to the viewport, then we would have to take into account the draw region correctly when we set up the scissor. So that I don't think would cause the problem that we're seeing, but I do, because it's actually moved down, so that's a separate thing. But I do want to just look up GL scissor on docs.gl so that I can verify to myself that those are being called properly. Let's see. Defines a rectangle in window coordinates. The first two arguments, x and y, specify the lower left corner box, width and height, specify the width and height of the box. So window coordinates, are those related to the viewport or not? I wish they defined their terms more clearly in the docs. You always end up having to go look back at the spec and stuff to figure out what they mean for window coordinates, right? Is that in the viewport space, or is that outside the viewport space? I have no idea, right? But anyway, so window coordinates have integer values at the shared corners of frame buffer pixels. Allows modification of only the lower left pixel in the window. So that sounds like, you know, if I had to guess, the scissor rectangle and the viewport rectangle are separate. So I can set my viewport and my scissor separately, and they both are in window coordinates. Which means that this scissor should technically be done in the bind frame buffer call, or rather I should say in the space of the frame buffer, right? So we really, I'm sorry, in the space of the draw region, right? So I think technically what we want to do here is say that whatever the draw region was, if we're in our, if we're in the target 0, we need to actually, you know, sort of unify those clipping rectangles, right? So we want to do something like rectangle, like clip rect equals intersection, or I guess it's not even intersection. It's really just an offset, because we know that the clip rect fits inside the draw region. So it's really just like I need to offset the clip rect by that amount, right? And I think we might even have a way to do that, right? Yeah. So we can just say the clip rect is an offset of the clip rect, right? By the minimum corner of the draw region, because I need to move that clip rect up in that case. So what I could do here is just say, well, the clip rect is either equal to itself in the case where the render target index, whatever that render target index is, right? Let's go ahead and get that out there. Or even better, this way this will work in both cases. I'll say, assume that's the clip rect. And then if we're going to... this is kind of a complicated if, because I need to make sure we work here. So I really need to say, if we have a valid render target index here, right, assuming that that's true at all, wait, do I need to do that? No, I don't need to do that. I take it back. So I guess now that I think about it, there's a couple things that we weren't really doing here quite right. So when we do the use render targets thing, and we do the if the render target is greater than, so we kind of need, I'm just trying to figure out how to handle both those cases. The clip rect thing is fairly simple, right? I can set the clip rect, and normally we would just use that clip rect if we didn't have the sort of problem with with handling aspect ratios and all that sort of stuff. So what we need to do is, if we know we're in the space of one of those separate render targets, which therefore doesn't need to use like the whole screen, it's sort of a more contained one, then we can just use the clip rect directly. But if we aren't doing that, then we need to make sure that we use the sort of normal space of the clip rect. And so what I need to do is say, you know, if we are using the render targets, right? Or I should say, if we're not using the render targets, we know we always have to offset. Or if we are using the render targets and the render target index in this case equals 0, in both those cases, then I need to actually make the clip rect equal the offset of itself with wherever the draw region is, right? And then regardless of what I do, I always do want to set the scissor, right? So I think that's the more correct thing to do there. I don't know whether they're rectangle 2i's or not. Yeah, they are. So I think that's right. And let me look at rectangle 2i here. Oops, 2i. So here we got a bunch of random stuff. I'm going to say that we've got a inline. And I don't know if we have. Do we have a v2i? Do we have an integer v2i? We don't really, do we? We just have regular v2s. I don't think we ever actually talk about v2i's. Yeah. All right, then I won't do that. I'll just say, like, okay, when we do the offset of the clip rect, I'm interested to know if getMin, how are we calling offset on a rectangle 2i if we didn't define offset of a rectangle 2i? Do we somewhere? We only have rectangle 2 and rectangle 3. I guess it just never finished compiling this thing? There we go. So it just couldn't resolve the function overloading. So I was like, that seems really weird. Okay, so if I have rectangle 2i and I want to do an offset call to it, which is what I would like to do here, I can just say, like, all right, I've got an offset call rectangle 2i, and then a s32x, s32y. And so the result is just equal to whatever we pass in. And then all of the values, right, just get added to. Right? So in this case, we've got the draw region min x and the draw region min y. And that should give us the actual clip region that we need. So I think that's correct. I think that is the correct way to look at the clip region that we weren't sort of specifying correctly before. And now in theory we are, I think. And of course, the slight problem with that is that's going to persist. So what we also need to do, I suppose, is when we do our initial clear, we would have to set our scissor correctly as well, if that makes sense. So when we do our clear, we have to do sort of a scissor that allows us to clear the entire region, whatever that is. And so I'm not sure what the easiest way to do that is without necessarily knowing what it is. So I think we may have to just kind of bite the bullet here and say, yeah, we have to clear the whole region. And in order to clear the whole region, we have to know the size. Now, what we could do is set the scissor wider than the window or something like that too. I don't know. But in order to clear everything, what we could do is literally just do the check if it's greater than 0 and C, right? So we could say here, you know, something like this. If the target index is 0, then we know that we need a frame buffer that's got the sort of the window width, if you will. So, you know, get width, draw region, get height. Well, actually, it's not even the draw region. It's bigger than the draw region. So I guess I don't know that we even pass that value down here, unfortunately. and I suppose we will have to. So we'll probably have to actually do window with window height, and those are different from the draw region, if that makes sense. Let me take a look at where we use window width and window height here. Yeah. So, yeah, and I don't know if all we use it for is that too. I don't know. It seems like if we are trying to do a particular render size too, it feels to me like these could also just be, like, how are we setting our viewport up here? When we set our viewport, based on whatever the size of these guys actually is. So, you know, if the target end is greater than 0, we set, so we are sort of saying, let's pretend it's always the draw region. So I guess that's okay. I guess I'm okay with that. And so when we actually go to clear these, we want to set the scissor, again, to get width of the draw region, get height of the draw region for these. But in order to clear the whole thing, we want to clear the window size, which means when we actually call this, we need to actually know how big the actual window is. Which, again, we don't really know, so we have to kind of pass this. We used to pass it, and then we stopped passing it. It makes me think we want to probably bundle these, because you can see how they kind of have to cascade down a little bit like that, which I don't love. But, you know, for now, I'm just going to do the simplest thing till I'm absolutely sure of that, if that makes sense. So, yeah. So, let's see here. I think this is dimension, right? Let's see. Yeah, so dimension width and dimension height. Should probably just take whatever that is and pass it down, but... Cannot convert 5 from memory into U32 star. What happened? Oh, right. It's right there. Okay. So, let's see here. Now I reset the scissor anytime we clear. So in theory, we should always clear the entire back buffer, which we are now, right? Because that scissor, one of the problems with OpenGL in the way that it, you know, kind of if when you use the original kind, is it's very stateful. So that scissor rectangle that we set will persist to the next frame. And that's why we were getting some clearing bugs, is because it's whatever the scissor was the last time through is what the clear would pick up. And you definitely don't want that, right? Okay, so at least we're setting the scissor now more correctly. Which means, and now I am getting exactly what I expected, this was the part that I was trying to fix first. Now we cannot draw down here, which is what I was like, I didn't like the fact I'm like, we're not setting our scissor regions properly, and like now I think we are, right? So we fixed that, but we still have one other problem, which is that when we're doing this split, you can see that the actual screen, its portion of the actual original drawing is getting offset downward. So it's like its offset is incorrect now. And so I'm not sure why we're getting that effect. And so we kind of need to figure out where that's coming from as well. So let's take a look here in Handmade OpenGL. I'm not 100% certain how that displacement would happen. Because my feeling is it probably has nothing to do with this operation. Meaning I think we could probably just not do this at all and still get the problem happening. Because it would have to be something about setting up the viewport on target 0. In light of that is what has to be happening, I think. And the reason I think that is just because Otherwise, how would it get shifted down? Because that operation just alpha blends something over the top. That shouldn't be sufficient. Yeah, and you can see it happen there, right? So it has nothing to do with this fact. I think all it is when you are toggling between those, something's wrong with our bind call. So when we do our OpenGL bind frame buffer, we're not like properly setting that up, I guess, right? Something is getting set wrong. I'm not sure exactly what, that's causing that sort of jump to occur there. So yeah, so I'm going to take a quick look and see what's happening in the bind call to see if I can get any sort of idea about why that would be happening. I mean, you can see that when we bind a target that's not 0, we're going to make the viewport be the whole size. But when we bind a target that is 0, it looks like we're doing the proper sort of min x, min y from the draw region. So I'm not sure why we would be getting that, but getting that we appear to be. So yeah. I guess one thing that that's the problem. We also have our transform here. I wonder if our transform is a problem because the transform has the width and the height in it. Yeah, but that wouldn't cause an offset. So what width and height are we using? We're using the width and the height. No, that should be okay. So here's something that vaguely tickles my memory. So here's one thing that I would like to try. I'm going to move this OpenGL screen space call down here so that we set the matrix every time through, just because I want to see what happens. Of course, I have to actually hit my jump. All right. It's all good. Now let's try this one. All right, so still getting the offset there. I feel like there was some thing that I'm vaguely remembering about OpenGL where like the viewport and the scissor or the perspective matrix are somehow dependent on each other in some way that's not obvious. I sort of getting that vague like thing in the back of my mind. Hopefully that's not what's happening here, but I'm a little bit nervous about that. Okay, so the first question I guess I have is maybe do we know that our viewport is being set correctly? Like maybe I'm just straight up setting it wrong because it looks like what's happening is the viewport is not getting reset when we switch back to target 0, right? That's what it looks like is happening because we would get the results that we're seeing. That's exactly what we would get if the viewport was only changed if the viewport was only doing this, right, and didn't get set back to this, that is exactly what we would get, right? So I'm curious to know how that's happening, like why we're not seeing it get reset. And I suppose I can verify that. I mean, not really verify it, I suppose, but I can at least test that by never doing that other viewport call. Yeah. and then we can verify that, you know, the other one's wrong, obviously, but ours is not. So that's good. So it looks like we're calling that one, and then either we're not calling the other one and should, like maybe for some reason this call isn't happening, which I don't know why, or this call is not having the effect that the call should actually have, right? And I'm not sure why it wouldn't, especially because this is the call that we actually are calling, right? Every time, right? So we call that for each clear, and then we call that to set up, you know, this is the call that we use to set up the frame buffer. So I'm not sure why we would ever, why having it flip like that would ever cause us to, you know, why having a second one makes that occur. I don't know. But maybe I do. So we would never call it a second time in here. We'd never call it in here, right? See, that's the thing. We would never call it even one time. Yeah. So maybe we just have it straight up wrong. So here's OpenGL bind frame buffer, right? And I'm going to force it through. That's the thing, is we weren't calling the right path. We were calling this path, right? We had a spurious call there. So let's see what happens if I just do it here. Well, no, that looks right. Okay, it looks that fixed the bug. So just the fact that we had to bind it up, it was using the viewport from the last time around, wasn't it? We just were never, it's the same exact bug as the scissor bug, right? It was calling GL viewport and it was never initializing the call to GL viewport, right? Because before, you saw what happened there, right? Before, I was only setting the target frame buffer. And I was assuming that we had set the viewport up here, but we never did. Because I took that out with the new viewport setting thing. So this would never actually happen otherwise. So you know what I should do? I should take a page from the playbook that we had up here and say, look, we've got a current frame buffer thing happening, right? And we're sort of tracking that current frame buffer situation. And I guess it's not really current frame buffer. It's like current render target index. We should set it to a bogus value. And we should just, that way we know we're always going through the same path instead of two different possible paths based on whether we hit this one or the one above it, right? So I want to do that. That way it's all nicely self-contained, and we know that we're always going through the same path. So that's what was happening. We weren't on the wraparound the next time we would draw a frame, it was still using whatever the viewport was from the last frame. Now, if you never had more than one viewport, well, then you wouldn't have a problem, right? Because you never have to worry about setting it to the wrong one and then using it, right, on the next frame. But we didn't have, once we hit the situation where we had more than one viewport, it was just going to be wrong. Okay, so I think that's all better. Like I said, that one wasn't on the issues list, but someone, I think Kim had mentioned it. So that's good. All right, so let's try wrong pitch. Probably would have been never caused a problem to optimize retards for Blender retard. The pitch to advance a source has been assigned the value of the pitch needed to advance it. So this looks like a typo. And they're talking about in here where we do, is the source row advanced? Yeah, okay. So you can see it here. It was just like some copy pasta there. We've got the desk target pitch should have been the source target pitch, right? So I assume that that is the only thing that they were talking about in that bug. And that wasn't causing a problem because, hey, all of the render targets have the same pitch, so technically you really don't need a multiple pitches, but just in case they ever did, it would have been wrong. So at least now we've got that. It's a bug that we don't have to solve later, right? So let me try hopping up the stairs here. Let's see here. All right. So yeah. So we'll try that. And switch back to the issues. So let's see. What else we got here? Let's see. So we got a bunch of OpenGL like stuff here. So let's see. From Iffy. Supposed to check. Also, apparently some cards used to be for ARB from the interview. We fixed the typo and we checked for the extension, but we couldn't find an ARB issue, so we're not sure about that. Maybe so. So this got reopened here. There is no ARB texture sRGB extension because sRGB textures move directly into core from X extension. So to determine support for sRGB textures, you need to check if the X extension is present or if the OpenGL version is greater than or equal to 2.1. You know, I really wish people took API design more seriously. I mean, really, guys? Really? Do you really think this was a good idea? All right. All right. So let's go take a look at that. Now, I don't even know how to check the core version. I think you have to look at what the vendor version string thing comes back. Let's take a look in here. Where's my info call? Yeah. So when we get the version here, I mean, are we supposed to parse the version string? Is that really... is that really a good idea? I mean, I guess we could look and see if the first part of the string is, you know, higher than or equal to 2. And if it's, you know, only equal to 2, then we'd have to look at the point to see if it was 0.1. That just seems crazy. I mean, I don't know what else to do. You know, I don't know if there's an OpenGL way to get... let me see if there's a get integer v for it. Because I'd rather not have a parser in here just to determine... isn't there like a GL get? Here it is. Yeah. So is there like a version in the GL get integer v? Like somewhere. Version. Okay. Whew! I was a little nervous there. All right. So at least we could say, after we do this, we could say, okay, GL get integer with GL major version, get integer GL minor version, and we could then do some testing on those. That's at least something. So let's go ahead and see get integer v. And we are going to go ahead and pass glint major, glint minor. We'll assume 1.0 because I think Windows always has at least that. And so we'll do the get integer v's on those, and then we can say, all right, if the major version is greater than or equal to 3, right? Or the major version equals 2 and the minor version is greater than or equal to 1. I guess that's what Martins was saying is the magic. So if we're basically greater than OpenGL, I guess I could say it this way to make it a little more clear. If we're higher than version 2 or we're on version 2.1, right, or better, then we know that we have our sRGB textures. Right. So I think that's right, but we'll take a look. Undeclared identified GL major version and GL minor version. Okay. Let me grab that for you. So let me step into that and see what happens here. So we come through here. We're going to hit this. We got a major of 3 and a minor of 0. So that's fine. We go ahead and look here and we say, okay, the major is greater than 2 in this case, so we're going to do this. We don't care. But otherwise, we would have looked to see if the major is equal to 2 or the minor was greater than or equal to 1. Right? So I think that's right. And then we'll consider that set. But that wasn't the only thing in this bug, assuming that we got that right. So we got the wiggle version of the frame buffer extension has the same problem. Needs to check arb frame buffer has to be as well as ext. Okay. So let's take a look at what's happening in that one. So in Win32 Handmade, we have sRGB. Let's take a look at that. So in here, we've got wiggle through the arb frame buffer sRGB. So it's just the same exact thing, looks like. All right. So in theory, we have fixed those. And by fix those, I mean sort of like provisionally fix them, because the people who rated them will have to test, since we don't really know if they're broken or not, right? We're just sort of hypothesizing that we fixed them, but we don't know. Okay, so we'll let that be reopened by anyone who can actually test it for us if they find that that's still not actually doing the checks properly. All right. So let's keep going here. Check GL init fallback. I can't find it now, but I believe Martin's posted a control flow bug with what happens if the ARB pixel format choosing fails. And so let's take a look at that. Here it is. Small bug when calling Win32 set pixel format in the Win3D-OpenGL function. It is called only for the modern context. If creating the modern context fails, this function won't be called, and creating the regular context will fail. So we want to do that where we do create context. Let's see. So we do the create context here, and we do wiggle make current. This is the preliminary context where we try to get the extensions, which is not really what we're looking for. We want the actual init call. So we say if we've got it, we set the pixel format, and we do wiggle create context attributes arb. Otherwise, we do wiggle create context here. So I'm thinking Win32 set pixel format. I don't think we ever don't want to call it, right? So I feel like we could just do that, you know, here, right? I mean, there's no reason why we would do it later, I don't think. So I think that would then make sure it always gets called. So I think that was just a cut and paste problem where we didn't do that, right? So, okay. I believe that's fixed. So I'll go ahead and put that in here. All right, so that bug is in theory fixed. Again, in theory, because we're not really testing these. These are just kind of preliminary fixes. And let's see. Unnecessary describe pixel format. So I was not sure about this one, to be honest with you, because I thought you did need to do it, but maybe you don't. And so let's see here. In describe pixel format, when we pass that suggested pixel format, the suggestion was that you could just not do that, right? That you could essentially just pass garbage, right, and do this. And I don't know whether that's true or not. I'm a little nervous about it, to be honest. Because I don't know if it always is really completely superfluous. So to be honest, I think I might just leave it in there. I don't know. Maybe I shouldn't. Let's see. I mean, I guess another question is, can you just pass 0? Like, can you do... that? Apparently you can. So is that an optional parameter of set pixel format, basically? At least on this card? So it's not technically defined as an optional parameter, but it is apparently only used in a very specific, not a case that is not related to ours, right? So you know what? I'm going to say, though, for completeness, that we should just leave it this way. Because just because it doesn't have any effect, it's not technically an optional parameter. So I think I'm going to resolve won't fix that one. So I'll make a note of it, but I think I'm going to leave that in because I don't see a real reason not to. So I'm just going to close that one as basically like I'm not going to fix it. Okay, let's go back to the issues list, getting smaller. So we've got, not going to touch that one because that's going to take a while. So that'll have to be a separate one. Let's take a look at some of these other ones. So use render targets. We still call the render target stuff. So what I'm going to actually test that one so that we can actually get some crashes and make sure that we've got it. So this is basically when we don't have render targets, right? So I'm going to go ahead and take a look at we'll get proc address here. There it is. So what I'm going to do is I'm just going to assume temporarily that we don't have GLR frame buffer object. In fact, I guess I can do that here. So now, in theory, we should just crash. Oops. Because we're not actually doing that check. We should just jump to an invalid location or something, right? And yeah, and we do. So here where we try to call GL frame buffers, we just jump into no man's land. So let's go ahead and now try to make it so that we do run properly, or at least as close properly as we can without those render targets. And let's take a look at how that would go. So here we are with use render targets. In use render targets, wait. Max render targets, so use render targets, command render max or 1. If the max render target index is greater than or equal to the global frame buffer count. How did we get in here? Because the global frame buffer count, oh, but it's greater than or equal to. So the max render target index should have really been 0. That's what actually should be happening there, right? So yeah, so that's much better. Okay, so I think then we just have to deal with the bind frame buffer call. Bind frame buffer. And in bind frame buffer, I guess we're just going to say, well, the target index, you know, if GL bind frame buffer target index equals 0. So we'll just always force it to render to target 0 in these cases, I guess. However, we may want to just not, like, you know, we may want to throw away all rendering that isn't, because like since we can't support it, I'm thinking maybe what we do is say if we're, you know, going to do GL bind frame buffer, if we can do it, we'll set the viewport to this. If we can't do it, we'll set the viewport to like nothing. You know? I don't know, that's not that compelling either to me, to be completely honest. Yeah. I'm not sure what the best way to handle this is. I guess we can handle it explicitly here by saying if we're using render targets, then we will do the OpenGL bind frame buffer there, and that would be fine. And then down here, when we would be doing an OpenGL bind frame buffer, I guess what we actually want to do here is say, you know, if we're actually trying to use render targets, then we'd want to bind the frame buffer. Otherwise, we want to actually kill this guy if he's trying to draw to something other than the one that he needs to draw to, right? So, you know, I guess what I would say is we'd want to enclose this whole thing, or to issue a continue, basically, right? We'd want to say, you know, don't do whatever it is that you're about to do. If this guy's render target index would have been invalid. Another way, I guess, to look at it would be to actually put it up here, right? So we would say, you know, if whatever this guy's render target index actually is, I guess we only really pull it out in this case. And we really don't want to access it every time, probably. Yeah, this is just a little janky. So, I mean, I guess... the part is I don't really want to have to do this. This is what the code would suggest that I do, is basically look at whatever the clip rect index is that we're getting. Whatever the clip rect is that we're getting, if its render target index is in range, then we're okay. Right? And so I don't super love that, but I think that's like roughly correct, at least in theory. And then I guess, yeah, at the end, the global blind frame buffers have to be predicated on that. And then that may be it. And so now, you know, it's a really graceful fallback too, I guess. You know, that it just pops in now if we don't have multiple render targets. So I feel like that's okay. I don't know if that's the most efficient way to do this. So what I might say too here is like, well, you know, we could say, you know, assert clip render target index is less than or equal to max render target index. Certainly. But in this case, we could say if we're going to use render targets or, right? So essentially saying like, hey, if we know that we're in render target mode, then just assume that that you should process this, so that we won't check every time if we don't have to. I don't know. So I think that's okay. Oops. And in theory, that should now work correctly in both cases, but let's make sure. Yeah. Okay. So I think that's all for that one. I do want to check, since we were monkeying with the bind calls there, I do want to check to make sure that, oops, not that. I do want to check to make sure that this guy works okay. And he does appear to. So that seems good. All right. All right, so I think that's good. What else do we have for issues? So asynchronous textures download we're not going to do today for sure. We only got, what, like 2 minutes left? I think. But we might be able to look at this one. Pack entity into chunk list. So that might be good. And I think that's the only one that's really a short one. So let's take a look at that one. Mocks from the forums. The linked list doesn't chain correctly. I believe the pack entity into chunk function has a bug in it. The code that creates the first block of chunk will also be called if there's no room left. At that point, the new block should chain the old block, but this is not done. This represents without remembering it. I think it should become this or something like that. Hopefully this will prevent any future problems. So let's take a look at that. That's pack entity into chunk. All right, so here is the part they were talking about first free block is this one, I believe, right? Yeah, so he's talking about this right here. And so let's take a look at what this is doing. We've got if there is no first block or there is no room, right? So we have either the case where we haven't allocated a chunk at all, or there isn't any room in this particular chunk for whatever it is that we're trying to pack into it. Then we look to see if there isn't a first free block available, then we create one on the free store, which seems totally fine, right? Because now we've just got one sitting there. We take the first block, yeah, and we immediately clobber it, which is not good, right? That is not what we wanted to do. So what we want to do there is something more like, we want to kind of push that down if there was one there. So we want to do like chunk first block next. I don't even know. This doesn't look, this whole thing doesn't really look all that right to me. But anyway, so the chunk in question here, right? I'm sorry, the block. There's there's a new block, so we'll take that, and it's going to be world first free block, right? So let's just name these what they're actually going to be. So this is the new block that we're going to use, and then world first free block is just going to be whatever the next thing was after that. So that just pops it off of the free list, right? And we're saying that there has to be one because we always allocate a new one, right? So that's all fine. And then what we need to do is we need to actually set chunk first block to something valid. So chunk first block is going to become whatever the new block is, right? But we want to remember whatever the new block actually... we want to remember whatever is supposed to come after that block, right? So we want to take whatever the first block was and chain that onto the end of us before we set ourselves as the new head pointer. So I think that's really probably all we needed there. I don't know if that's similar to what he was suggesting. Yes, but he did it a slightly different way, but yes, basically. So I think that's it. And we don't have much of a way of testing that right now because we don't stress test the entity occupancy system at all. We haven't really done much with that. All right. But I believe that's okay. Oops. Okay, so let me just take a quick gander back at that just to make sure that I believe that was a reasonable fix. Again, we grab the new block off of off the free block list, and we advance the free block pointer forwards one. We then say that whatever the first block is for this chunk, we make that our next pointer, and then we make our cell the first. Yeah, so I think that's pretty reasonable. We then clear that block, which seems fine. All right, so let's go ahead and go to the Q&A. I think we're done with most of these. So that's pretty good. We're down to not too many more issues. This is not really an issue, right? But yeah. All the rest of them are... and this one is more... These two are basically project things. So really it's this one, and this one are the three that we actually have to do. Snoring Tortoise, not sure what the minimum OpenGL version of the game supports, but according to https OpenGL.org wiki get context info, the GL major version, GL minor version are only available in OpenGL 3.0 and above. Well, that means we will have to parse then, I guess. Which sounds awful. I mean, that just seems really error-prone, because we don't even know what the format of that string is, right? We have an example of what it is. But if we're not going to do that, right, then we would have to actually do like a... you know, what's the name of what's the version here? Let's see, result.version. So we'd have to do something like if at 0 equals dot, you know, major at equals minor at equals something like this. So we could do something, well, actually, you know what, I'd probably do. So we could say, like, okay, if we found that, then we would basically just say, like, okay, the dot is here, and the minor at is, you know, one past here. And we break, and then we just say, well, if we found the minor, at, you know, I don't know what we'd say, something like the major version, the minor version, we assume are 1 and 0 or something. Assuming that we found the minor at, we'd say major equals parse, you know, OpenGL parse number, major at, and then we'd say something like the minor version, minor at, like that. And then we'd need a little thing here that parses an integer. Can't believe anyone ever thought this was an okay thing to have in an API, but yeah, I don't even want to know. I stopped asking these kind of questions a long time ago. So this is like the string. And so then we've got a result. Right, we're just going to do like while, you know, at is greater than or equal to 0, and star at is less than or equal to 9. We're assuming it's a digit. So we're going to take whatever the result was and multiply it by 10, right? Because we're parsing a string. So the first thing we're going to see, we're going to read it in, and we're going to assume it's a digit. And then every place we move over, it means that the digits we saw beforehand go up by a power of 10, right? So we take whatever our accumulator is, we multiply by 10. And then we add in whatever at was, right? I guess. So let's take a look at that. That beautiful piece of code. That shining, stellar example. Let's go ahead and take a look. Where's my OpenGL? There it is. Oh, I was already in it. Well, there you go. All right, so we come in here. And let's see if we correctly identified our major at and minor at. We did, so that's good. I don't know why. I guess I don't need the dot. So we can pull that out of the code. I was thinking I might need that, but I guess I don't. So assuming that I actually got those out, oh, and you know, might help if you put a plus in there somewhere, folks. There we go. Gonna be in that loop a long time. Oop, I want to actually go see what that did. There we go. So major and minor here. Major is 3, minor is 0, so I think we're good. So there you go. All right. So I guess that's okay. Hopefully that helps. Thanks for pointing that out. That would explain why they weren't defined anywhere. Let's see. So I'm designing a 3D game engine and want to first write a software renderer for it to learn more about renderers. Do you think I should go straight for OpenGL or software renderer and then OpenGL? I'm not sure I understand the question because it seems like you said in the predicate to the question that you wanted to write a software renderer. So if you want to write a software renderer, then you should write a software renderer, I guess is what I would say. Yeah, and insofar as I didn't want to use scanf because it's just going to be another thing we have to remove when I remove the C runtime library. So if it's easy enough to write a parser, I just write it. All right. I don't see any more questions, so I'm going to wrap it up. All right, everyone. Thank you very much for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can always go to handmadehero.org and pre-order the game. It comes with a source code so that you can experiment yourself. And, you know, you can find bugs and report them on the issues page, too, so I can fix them. A bunch of those were reported by people who play with the source code. We also have a forum site if you want to ask questions. We have a Patreon page if you want to support the video series, a schedule bot if you want to know when we're going to be live, and a past episodes guide where you can go to catch up on old stuff we did. That's about it. I'll be back here next week. Until then, and if you want to know when, check the schedule bot. Until then, have fun programming this weekend, and I'll see you guys on the internet. Take it easy, everyone.